Virtual worlds are on the brink of a transformation, thanks to Microsoft's Muse AI, a groundbreaking system that doesn't just follow scripts, but truly understands how objects move and interact within digital environments. Muse, short for World and Human Action Model, WAM, is designed to generate both visuals and action simultaneously, making it a powerful tool for game development and beyond. Unlike traditional AI, Muse is trained to comprehend 3D game environments and game physics, enabling it to create gameplay sequences that feel natural and immersive. This isn't just theoretical. Muse has already been demonstrated in action, generating visuals at 300 x 180 pixels resolution, a significant improvement over earlier prototypes. The inspiration behind Muse. The idea for Muse emerged in late 2022, shortly after ChatGPT showcased the potential of transformer-based models for text generation. Katja Hoffman, a senior principal research manager at Microsoft Research in Cambridge, UK, wondered if similar models could be applied to video games. Her team, Microsoft Research Game Intelligence, had already collected extensive gameplay data from Ninja Theory's Bleeding Edge, a 4v4 Xbox game released in 2020. With player consent, they captured over 1 billion images and controller actions, equivalent to more than 7 years of human gameplay. This massive dataset became the foundation for training Muse. The team used powerful compute clusters starting with V100 GPUs and later upgrading to H100 GPUs to train the model. Scaling the process was challenging, but they eventually stabilized the pipeline, enabling large training runs. The result was a prototype capable of generating gameplay sequences that matched real-world physics and player behavior. How Muse works: consistency, diversity, and persistency. Muse's capabilities are built around 3 key principles: consistency, diversity, and persistency. Consistency ensures that the generated gameplay adheres to the rules of the game world. For example, characters won't walk through walls, and button presses will produce realistic actions. Diversity allows the model to create a wide range of scenarios, preventing repetitive or monotonous gameplay. Persistency ensures that changes made to the game world, such as adding a new character, are maintained realistically across subsequent frames. These features make Muse a valuable tool for game developers who need AI systems that can handle complex dynamic environments without breaking the game's internal logic. Muse in action, demonstrating its potential. Microsoft has developed a WAM demonstrator, a prototype tool that allows developers to experiment with Muse. Users can load initial frames of bleeding-edge gameplay or even a single promotional image, and Muse will generate follow-up sequences. The model can also take button inputs and predict how the game would respond, showcasing its understanding of game physics. During demonstrations, Muse generated gameplay sequences at 10 frames per second, a modest but promising start. In one example, objects were dropped into the environment, and Muse rearranged the scene logically, demonstrating its ability to adapt to real-time changes. While the resolution is still low compared to modern gaming standards, the potential for real-time AI-driven interactions is clear. Driven in open sourcing Muse, encouraging innovation, Microsoft has taken a collaborative approach with Muse, open sourcing the model weights, sample data, and an executable for the WAM demonstrator. Researchers and developers can experiment with Muse on Azure AI Foundry, exploring its capabilities and building on its foundation. A detailed paper published in the journal Nature highlights Muse's potential to bridge the gap between text-based generative AI and video game AI, marking a significant milestone in the field. Applications of Muse. From prototyping to game preservation, Muse's potential applications are vast. For game developers, it could streamline level prototyping, enabling rapid exploration of new ideas. It could also assist in modernizing classic games by learning from recorded gameplay data and rendering them on new platforms without the original engine. This could breathe new life into older titles that are no longer playable due to obsolete hardware. Microsoft Gaming CEO Phil Spencer and other executives have expressed interest in using Muse to revive old games and create new interactive experiences. Some Xbox teams are already exploring how generative AI can enhance existing games or introduce entirely new gameplay mechanics. Short, AI-powered demos might soon appear in Copilot labs, giving players a taste of these innovations. The human touch, AI as a tool, not a replacement. While Muse's capabilities are impressive, there are concerns about its impact on the gaming industry. In 2024 alone, 10% of game developers lost their jobs due to layoffs, raising fears that generative AI could replace human artists and designers. However, Microsoft and its partners emphasize that Muse is intended to augment, not replace, human creativity. Dom Matthews, head of Ninja Theory, explains that the goal is to make the development process more efficient, freeing up time for developers to focus on tasks that require a human touch. Muse is seen as a tool to enhance creativity, not eliminate the need for human input. The future of Muse, real-time interactive worlds. Looking ahead, Muse could revolutionize open-world games and creative sandboxes, enabling environments that adapt in real time to player actions. Imagine games that expand dynamically based on player input or levels that evolve in unexpected ways. For players, this could mean new opportunities to co-create with AI, designing levels or challenges on the fly. Muse also holds promise for game preservation, potentially bringing back retro titles that were previously inaccessible. This could allow a new generation of players to experience classic games in a modern context. Challenges and ethical considerations. Despite its potential, Muse faces challenges. The current low resolution of generated visuals is a limitation, though improvements are expected as the technology evolves. Additionally, the ethical implications of AI in game development must be addressed. Ensuring that AI tools like Muse are used responsibly and do not lead to further job losses in the industry is crucial. Muse's potential beyond gaming. While Muse is primarily designed for gaming, its applications could extend far beyond virtual worlds. Industries like film, architecture, and virtual reality could leverage Muse's ability to generate realistic, interactive environments. For instance, filmmakers could use Muse to prototype scenes or create dynamic backgrounds, while architects might employ it to simulate building designs in real time. Virtual reality experiences could also benefit from Muse's adaptability, creating immersive worlds that respond to user actions. By expanding its scope, Muse could become a versatile tool for creative professionals across multiple fields, revolutionizing how we design and interact with digital spaces. The role of AI in creative collaboration. Muse exemplifies how AI can serve as a collaborative partner rather than a replacement for human creativity. By automating repetitive tasks like level design or physics simulations, Muse allows developers to focus on storytelling, character development, and innovative gameplay mechanics. This collaborative approach could lead to richer, more engaging games that blend human ingenuity with AI efficiency. However, striking the right balance between automation and human input will be critical. Developers must ensure that AI tools like Muse enhance creativity without overshadowing the unique perspectives and emotional depth that only humans can bring to the creative process. Ethical and accessibility considerations. As Muse and similar AI tools gain traction, ethical considerations must remain at the forefront. Ensuring fair use, preventing job displacement, and maintaining transparency in AI-generated content are essential. Additionally, accessibility is key. Muse's open-source approach is a step in the right direction, but efforts must be made to ensure that smaller studios and independent developers can also benefit from this technology. By addressing these challenges, the gaming industry can harness Muse's potential responsibly, fostering innovation while preserving the human element that makes games truly special. The future of gaming with AI is bright, but it must be built on a foundation of ethics and inclusivity. A new era for gaming and AI. Microsoft's Muse AI represents a significant leap forward in generative AI for gaming. By combining 3D environment understanding, game physics, and real-time adaptability, Muse opens up exciting possibilities for game development, preservation, and player interaction. While challenges remain, the potential for Muse to enhance creativity and efficiency in the gaming industry is undeniable. What do you think about Muse and the role of generative AI in gaming? Are you excited about the possibilities, or do you have concerns about its impact? Let us know in the comments, and don't forget to subscribe for more updates on the latest in AI and tech. Thanks for watching, and we'll catch you in the next one.